Welcome back. Now this is just the continuation of part 1. What I did was I just wrote the 30 degrees up. I erased the quadrantal angles and I just wrote the 30 degrees up. So we have finished calculating the 30 degrees. The next thing we do now is we are still on this theorem. We are still on this theorem. So let us go ahead and find 60 degrees. Let's draw our circle as usual. Then the same theorem, we explained this theorem on part 1. In this case, instead of 30, this is now 60 degrees here, rather than 30. And if you look at this, this is still your arrow, this is still your right triangle, this is your y, and this is your x. Now, do you notice something here? Compare, if it was 30 degrees, you see that the shorter was y and the longer was x. But in 60 degrees, the shorter is x and the longer is y. Because remember, if it was 30, it was like this. We drew it like this. So the same theorem still applies. That is why I did not erase the theorem. The theorem still applies. It's a 30, 60, 90, because here this will now be what? 30 degrees. You know, the sum of the angles of a triangle is 180 degrees. This is 60, this is 90, this will be 30. In 30 degrees, you know, we drew it like this. The shorter was the y, the longer was the x. But in 60 degrees, the longer is the y and the shorter leg is the x. The hypotenuse is still the same, hypotenuse. So length of hypotenuse r is equal to 2 times length of the shorter leg, in this case is x. And of course, this is unit circle, so r is 1, equal to 2x. So 2x is 1, and that is x will now be what? 1 over 2. Remember what I want to do, folks. Remember what I want to do? I want to find 60 degrees x, y. That is what I want to find. The x, y, the coordinates. We explained this in part 1. Okay? So, I've already found my x. I will write that x. I've already found my x, which is 1 over 2. So, xy will be 1 over 2 and what? Now, we found that the x is 1 over 2. Then the length of the longer leg is root 3 times square root of 3 times length of shorter leg. So, length of longer leg, y, is square root of 3 times what? X. So y will be square root of 3 times 1 over 2. And y will now be what? Square root of 3 over 2. So this is y, this is x, and this is y. Square root of 3 over 2. That is what we need, the coordinates. Let's go ahead and write the trig functions. Now, 60 degrees. You ask yourself, how do you convert this to radians? 180 is pi radian. What will you do to 180 to give you 60? You divide by what? 3. Right? So this is pi over 3. Just like you divide this 180 by 6 to give 30. You divide 180 by 3 to give 60. So it's pi over 3. That's it. Now, sine theta is y. Remember, this is xy. Remember what we wrote initially? That first time, I think I used this. xy. Okay? In this case, sine theta is y. So sine 60 degrees is square root of 3 over 2. Cos theta is x, which is cos 60 degrees is 1 over 2. Tan theta is y divided by x. So this is y divided by x. Square root of 3 over 2 divided by what? 1 over 2. So this is square root of 3 over 2 times 2 over 1. And that is square root of 3. Square root of 3. Cosec theta is 1 over y. This will be what? 1 over 1 divided by 3 over 2. 1 divided by root 3 over 2 will be what? 2 over root 3. Right? And then rationalize it. Rationalize this times root 3 over root 3. And that is 2 root 3 over 3. So you have here 2 root 3 over 3. Sec 60 is 1 over x. 1 divided by 1 over 2 is what? 2. Then cosine 60 is 1 over root 3. I mean, if you're doing it 1 over tan. Otherwise, you do x over y. X over y is what? 1 over 2 divided by root 3 over 2, which is 1 over 2 times 2 over root 3. Bam, bam. So you have 1 over root 3. Rationalize it. Rationalize it times root 3 over root 3. And that is root 3 over 3. Okay? Do you see the pattern between 30 and 60? I mean, but I want you to know how to get it from first principle, from unit circle. Now, we have another method. You know, we have another method. If you don't want to learn it by unit circle, you could learn it by reference angles. You know, we're coming to that anyway. We'll come to that. You can learn it by triangles and reference angles. Yeah, you can learn it that way. We shall do another video, another videos on that. How you can find the trigonometric functions of special angles other than unit circle. You have to use triangles and reference angles. That is another method. Okay, we are finished with 30 and 60, right? The next thing, remember, special angles are the multiples of 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We've got the quadrantal, we've got 30, we've got 60. Let's finish up with the first quadrant, 45 degrees. Okay, let's get the 45 degrees. So in this case, we will have another theorem. We will have what? Another theorem. We will have another theorem. Theorem on 45 degrees, 90 degrees, triangle. And in this theorem, when you have 45, 45, 90, because 45 plus 45, 90, 90 plus 90, 180. Now, you know with a 45 degree, it is an isosceles triangle. You know it's an isosceles triangle. This is an isosceles triangle. Okay? Which means two sides are equal. Now, the length of hypotenuse. Now, two sides are equal. Okay, so two legs are equal already. Two sides are equal. So we don't have the shorter leg and the longer leg. No, both legs are equal in an isosceles triangle. So you only have hypotenuse and the legs. So you have the length of the hypotenuse. Length of the hypotenuse is equal to square root of 2 times length of either leg. Length of either leg. Length of the hypotenuse is equal to square root of 2 times length of either leg. So let's look at how this works here. Let's see how it works. You see, this is, is this difficult? Are you understanding it? Si habla español, comprender, comprenez-vous? Okay, let's have this, let's have a circle here, the unit circle. If we divide that into four quadrants, into the quadrants as usual, and of course this is at the origin, half of this 45 degrees. We have 45 degrees here. Okay, 45 degrees. That's what we want. And what do we have? What do we want now, folks? We still want our x and y. This is 45 degrees. The legs are the same. Okay, y and x are the same. They're the same. And of course, this is your R. This is your right triangle. Make sure you always put the right angle. Because without the right angle, it is not a right triangle. You've got to put that right angle. If you don't put the right angle, it is not a right triangle. That is your geometry. Okay, now let's look at this theorem. The length of hypotenuse, R, is √2 times either leg, okay, times x. And of course, our R is 1. So 1 is equal to √2 times x. So x √2 is equal to 1. √2 times x, which is x √2. You don't say √2x. Please, you don't do that. The variable will come before the radical. Variable comes before radical. You can't put √2x. No, you have to put x √2. And then divide both sides by √2. So x will be 1 over √2. Rationalize it. It will now be what? 1 over √2 times √2 over √2, which is what? √2 over 2. So our x is √2 over 2. And our x is equal to y anyway. So our y is also √2 over 2. If you want to do it √2 times y, that is fine. Okay? So x and y will be √2 over 2, √2 over 2. That's for 45 degrees. Okay? So now let's get it here. We have 45 degrees here. 45. What will you do to 180 to give you 45? That's the thing you will now ask yourself. How will you do that? Okay? Let's say 45 times x equal to 180. How about we do this, right? So x will be 180 over 45, which is, of course, 180 is pi. You know that 180 is pi. But let's go ahead and do this. This is 20 over 9 to 18. 9 to 180 is 20 over 9 to 45 is 5. So this is 4. So this means 180 over 4 is 45 degrees. So this is pi over 4. Pi over 4. You do the conversion right away. Pi over 4. Right? 4 times 4. 4 times 5, 20, 0 to 16 plus 2, 18. Okay, now sine 45 is y, √2 over 2. Cos 45 also is √2 over 2. Tan 45 is y over x. √2 over 2 divided by √2 over 2 will give you 1. That's 1. Cosec 45 is what? 1 over y. So that will be 1 divided by what? √2 over 2. 1 times 2 over √2. Okay, this is 2 over √2. Rationalize it times √2 over √2. That is what? 2 √2 over 2. Are you with me? 2 √2 over 2. Bam, bam. That is just √2. This is just √2. Sec 45 will still give you what? √2. And then cotangent 45 is still what? 1. That's the 45 degrees. We have got 30, 60, 45. Let us now talk about what we call reference angles. When we talk about reference angles, you see how the work will be simplified for us. At least we would do reference angles of 30 degrees at least. Then we will probably have a part 3 of this video, yeah, so that we can complete the rest of it. What are reference angles? That is the next thing we'll talk about. So we can remember, the special angles we talked about are the multiples of 30, 45, 60, 90. Okay, so if because we want to finish 30 tonight, we really want to finish 30 tonight. So when we talk of 30 degrees, this is times 1. 30 times 2 is 60. 30 times 3 is 90. 30 times 4 is 120. 30 times 5 is 150. 30 times 6 is 180. 30 times 7 is 210. 30 times 8 is 240. 30 times 9 is 270. 30 times 10 is 300. 30 times 11 is 330. 30 times 12 is 360. Okay? We talk of 45 degrees. 45 times 2 is 90. 45 times 3 is 135. Right? 45 times 4 is 180 degrees. And the rest of them, okay, and the rest of them. Now, we will come more on this, but let's focus on reference angles. Then we do, because we will get some of these right away after we discuss reference angles. Now, what are reference angles? Later on we will finish listing all this probably in the next video. Now, what are reference angles? Reference angle is a positive acute angle. Number 1 is a positive angle. Number 2 is an acute angle. Remember, an acute angle is an angle that is less than 90 degrees. So it's a positive acute angle that the x-axis, it could be positive x-axis or negative x-axis, makes with the terminal side of an angle. When you draw an angle in standard position, find the terminal side. When you find the terminal side, just look at the angle that the x-axis makes with the terminal side of the angle. That positive acute angle that the x-axis, it could be positive x-axis or negative x-axis. The positive acute angle that the x-axis makes with the terminal side of an angle drawn in standard position is what we refer to as reference angle. Look at what I'm saying. I'm going to write the definition, but this is what I'm saying here. If we have this, because we want to do reference angle of 30 degrees. Right? This is x, this is y. And remember, our aim is always to find the coordinates. That's what we want. So now, this will be 30 degrees. This is 30 degrees. Right? Now, this is the initial side. Okay, and you move the angle. Now, you also have here, folks, if you have here 30 degrees, remember, it will make it with the x-axis. This is still x, okay? It will have to make the positive acute angle that the terminal side of the angle drawn in standard position makes with the x-axis. That is reference angle. Then you also have this here, 30 degrees here. And then you also have this here, 30 degrees here. So if you look at this now, folks, now this is our 30 degrees. We already know that 30 is our x is root 3 over 2 and our y is 1 over 2. Okay, now I'm going to show you something now. What is this angle here? What do you think this angle will be? If you come here, bam, here, what is this angle here? You see that? Now this is 90 already. You know this is 90. Okay? And if this is 90, here is what? 60. Here is going to be what? 60. 60 degrees. So 60 plus 90 is what? 150. This is 150 degrees. So you have 150 degrees here. Okay? I'm going to just write it here. Let me just write it close here. 150 degrees. Then, if you come from here, you see that? What's that angle? This is 180. The straight line is 180 plus 30. 180 plus 30 is what? 210 degrees. So this will be what? 210 degrees. And you see that these are multiples of 30. That's why I listed them. We'll get some of them now, okay? Multiples of 30. Then, if you come again, bam! See that? You start from here. Okay? Terminal side. Terminal side. This is the terminal side of this angle. Okay? This one is terminal side of that angle. Now, what is this entire angle? This will be, of course, this is 270. 270 plus 60. Because this is 60 here. Okay? If you look at this, this is going to be 60. So, everything here is 270 plus 60 gives you what? This is 330. 330 degrees. 330 degrees. See that? Okay. You want to simplify this now. You can now do that. You now see that in this case, the reference angle is just, the only thing here is that here, the x is negative, but the y is positive. X is negative, y is positive. So this will be, this is still x, and this is y. The only thing is that this will be negative root 3 over 2, because in this quadrant here, second quadrant, this is the second quadrant, x is a negative here, but y is still positive. So this will be negative root 3 over 2, and the y is still positive, 1 over 2. That is the 150 degrees. Then you come over here, first, second, third. Third quadrant. In the third quadrant, x is negative, y is negative. So this is negative root 3 over 2, negative 1 over 2. Okay? Negative root 3 over 2, negative 1 over 2. Then you come here, fourth quadrant. X is positive, but y is negative. So x is positive, root 3 over 2. Y is negative, negative 1 over 2. That is it. Negative 1 over 2. So we now come here, we have 3 more angles to fill up. We have 150 degrees. Okay? We have 210 degrees. And we have 330 degrees. Okay? We are going to fill up everything. We will fill up every single thing. We will. Okay, 150 degrees. X sine theta. What well, let's find the theta in radian. Okay, so you ask yourself, what will you multiply by? What will you multiply by 150 to give you 180? Right? Let's find out. What will you multiply by 150 to give you 180? 150 times x equal to 180, because 180 is 5. Right? So x is 180 over 150. Let's find what x is. This will be 3 into 18 is 6, and 3 into 15 is 5. Right? So if you come and do 180 divided by 6 over 5, are you with me? If you do 180 divided by 6 over 5, because that is what 180 divided by 6 over 5. Right? So this is 180 times 5 over 6. You see? And that is 150. So this means pi times 5 over 6. So this is 5 pi over 6. 5 pi over 6. So this is 5 pi over 6. Right? Sine 150. Sine 150 is what? Y. Remember, this is our, let me just put here immediately, xy, xy, xy. Okay? Sine 150 is y, so this is 1 over 2. 1 over 2. Cos 150 is x. This is negative root 3 over 2. Tan 150 is y over x. So 1 over 2. If you see this, what is the only thing remaining here? You see, 30 and 150 are almost the same thing. If you do 1 over 2 divided by negative root 3 over 2, right? Negative root 3 over 2, you just have negative root 3 over 3. So you don't kind of waste time trying to do it again. Don't want to do that. Cosec 150 is 1 over y, which is 2. The only thing that changes is the x. That is only the thing that changes. Sec 150 is 1 over x, which will give you a negative 2 root 3 over 3. Cotan 150 is x over y. Okay, if you do x over y, this will give you negative root 3. That's it. The next one, let's do 210 degrees. Let us convert it to radians first. Now we can use a simple approach to actually convert it to radian, because some of you might ask me, hey, what did he do for the 150? What did he do for 150? Okay, see what we can do. See what we can do that is pretty much straightforward to convert to radians. We can do this. Let me use this area. You can use the method of proportion. Why don't you use the method of proportion? Right? So if you have a degree and you have radian, use method of proportion. So you see that 180 degrees is pi radian. So 210, what will it be? You can now say x. You can have it this way, you know. Method of proportion. So if you write it, you can cross multiply. Okay, you know that they already 180 over 210 is equal to pi over x. So 180x is equal to 210 pi, right? So x is equal to, divide both sides by 180. This is 210 pi over 180. 0 divided 0 is gone. 3 can divide, this is 7 pi over 6. 7 pi over 6. So you could do it this way. I mean, I think this is more simpler to comprehend. You can use proportion for all those angles in degrees. just know that 180 is pi. Then you now find the other one, you put x to find the equivalent degree. That's to find the degree that you want to convert to pi. You can put x in there to convert it to the radians. So you could use the method of proportion, right? Now, let's go ahead and find this. Sine theta is y, and that is what? Negative 1 over 2. This is negative 1 over 2. Cos theta is x, which is negative 3 over 2. Negative 3 over 2. Tan theta, because this is like this divided by this. So you have negative divided by negative. Because you don't need to waste time coming to do all this again. You could kind of, you see the equivalency there. Negative divided by negative, this will give you positive. This is root 3 over 3. Cosec theta is 1 over y. In this case, that would be negative 2, because this is 1 divided by negative 1/2. So it's going to be negative 2. Sec theta is 1 over x. And that will give you a what? Negative 2 root 3 over 3. And then cosine theta is negative divided by negative. Right? It's still negative divided by negative. Or 1 over tan theta. And that will be root 3. That is how you get your 210 degrees. Then the next one, let's do this one before we do part 3. So this video will not be long. 330 degrees. What is the conversion to radians? Here we can just say that x is 330 pi over 180. Right? It's 330 pi over 180. Because this will be 330 then. And this goes here. This will be 11 pi over 6. 11 pi over 6. 11 pi over 6. Sine 330 is y, which is negative 1 over 2. Cos 330 is x, which is root 3 over 2. Tan 330, of course, this will be a negative. So this is negative root 3 over 3. You see that? You see how the equivalency makes the work simpler. Cosec theta 1 over y. Y is negative, so this is going to be negative 2. Sec theta 1 over x. Yeah, x is positive, so this will just be 2 root 3 over 3. And then cotangent theta should be a negative 2, because one of these is negative. So cotangent theta is also a negative. This will be negative root 3. Okay, so please hang in there. Part 3 we shall do 45 degrees and 60 degrees, and that will complete it for unit 7. Then we can look at the other method we talked about for finding all these without using unit 7. Thank you so much for listening, and you have a good evening.